Swayam Prabha. Digital India. Educated India.
Hello. So today we will be discussing the last section of module 4. Earlier in module 4 we have seen the materials required for fabricating vacuum systems. We have also seen various components, valves, couplings, etc. So with all these things, what you will be doing finally? You will have to assemble them to make a system. So within this section, we should also end this section with final assembly, because the purpose of all these components and materials is to get the final assembly for a particular application with the required vacuum. Okay. That is what we will try to concentrate in this lecture. The concepts that are being covered in this lecture are how to do the initial testing. This is called initial testing, because it is the virgin test. Just after everything is done, manufactured in the site, we are trying to assemble it in the manufacturer's site. Later, after getting the acceptance from the customer, it will go to the customer site. There they will also test it for the actual application. So, these manufacturing experts should go there and participate there to make a success of the application. So, everything depends on the materials that you choose, the chambers that you weld, the components that you attach, the O-rings that you are taking, and the gauges that you are taking, how are you assembling it in a neat room, and how are you taking all precautions so that you will get vacuum, you will also get sufficient pumping capacity while process is on. So, it is a matter of knowledge on everybody. It is not only a customer's knowledge, not even producer, even the welder, even the fitter, everybody should have knowledge of vacuum technology. So, that way the outgassing and leak testing methods go hand in hand in testing the system, vacuum system. And there are different types of treatments to be given on the spot depending on the problem that you are facing, like surface treatment, passivation or bake out of the vacuum system. Sometimes if joints are doubtful, you will have to improve the joints, and if it is not a big vacuum, you can put some sealing compounds, etc. Such tips also we will tell you at the end, and then we will try to conclude with a feeling of initial testing of a fabricated vacuum system from various couplings and components and chambers. Okay. When I say initial testing, because first time you are making a system after designing various things, and this should be done keeping in mind the process application. And if you do not do, finally it will not work properly. So, you should give utmost importance in the initial testing, so that it will run smoothly in the actual operation. Okay. So, the manufacturer who makes the system and the customer who is going to accept the system, both of them should work together to improve the system. It is not the headache of only manufacturer, because it requires a lot of scientific concepts and technical excellence, etc. So, while you are testing it for the ultimate vacuum without any process, you should concentrate only on surfaces, chambers, welds, etc. But later you should also give a process equivalent to load, because process will not be there in the manufacturer's site. You can let in some pure gases to represent the load. Again with that load also you can test the chamber. When you are loading, the total load, that is called total throughput, should match the effective pumping speed available at the chamber and the working vacuum, the effective vacuum that you are getting, the equilibrium vacuum, that should be satisfied. Then only the customer also will be happy. In spite of the load, the pumps are working properly, chambers are working, gauges are working, and he also wants to have a satisfaction that without any load it is going to very good vacuum. So, very good vacuum means ultimate vacuum of a system, that is usually related to unavoidable background throughputs, which are leaks and outgassing. So, it should be always kept in mind in all parties concerned to reduce this background throughputs, whether it is a leak or an outgassing. There are standard procedures for it. Different companies have got different capabilities and standards. If ultra high vacuum companies deal with outgassing in a totally different manner. Leak also, very small leak is not acceptable for them, but it is okay if the system is working at 10 torque. So, you should know when to neglect a problem and when to be very fussy about even very small problems, because I told you in earlier classes, even few micrograms of gas can upset your vacuum level by one order. That should be taken into account. So, how to go about doing these things in the practice? There are few steps to understand the performance of this system under first initial testing. What are those things? The main chamber, all the components, flanges and center rings should be cleaned with suitable cleaning agent, and also use lint-free tissue papers. You cannot use anything you like while cleaning. If you use a dirty cloth, instead of cleaning, you are actually giving contaminants to it. So, you should be very careful. It is not like in road shops, the fellows who are repairing the car engines and all, they will be using even oily cloths to clean things. You should be very careful. You should not do such things in ultra high vacuum. You use little bit and throw it. So, lots of tissue papers, very high quality you should use with little bit of carbon tetrachloride or acetone if necessary, and purge it with dry gassing and see to that no moisture is left out. Use gloves so that the moisture is there on your hand, should not go there, because 1 cc of water will create 1 billion cc in the vacuum, ultimate vacuum. So, you should keep all these precautions, and if necessary little bit of greasing of the o-ring should be done, so that if there are inside flaws or some occluded gases will not come out into this, and surfaces look shiny and sealing will look very neat. Okay. But do not apply too much grease, and unwanted portions do not apply grease, it will unnecessarily degas. So, and greases are just not allowed at all if it is ultra high vacuum. But most of the time in day to day life we are bothered about high vacuum, -6 star, etc. So, there if we are very careful, we will be able to get -6 star. But you should tighten all the nuts or KF couplings, etc. after getting little bit vacuum again, because under vacuum all the flanges are getting pressed. So, original tightening might have got loosened. So, you should again tighten it. This many people do not do it. I have seen in my laboratory when students have done everything and they are getting -5, and ask them you tighten again, then it comes to -6. -5 to -6 is an enormous improvement. It may be only not small micrograms of gas, but quality of the output will be very good, whether it is a semiconducting device or a metallurgical piece or a thin film coating for research purposes or an optical coating or sensors. So, one small improvement can lead to one order of improvement in the ultimate vacuum. And while evacuating, suppose you get only 10 millibar in the initial evacuation, that means initial evacuation. Total evacuation may be up to -6, but it contains initially with rotary pump alone up to -2, but you are not getting even that. You should not get nervous, something is happening, it is not at all working as per my standards, and next to you customer will be sitting. No, it may be one day before, it was a rainy day, or people who have cleaned it have left some sweat or something, and that moisture is heavily getting evaporated, we can call it degassing, and if it is occluded to the surfaces, we can even call them as desorption. These are all interchangeable words. All this load is coming heavily and rotary pump is unable to remove it, because in the compression stroke it again gets condensed. So, you will get stuck at a particular vapor pressure of the water vapor. So, what you should do, immediately run the air blast for some time. Air blast operation we have explained in the rotary pump class. If you want, you can go back to that class and understand. And again close it. During this process, if vacuum is improving, then you are going towards better. And always I have seen also, once problem looks very major, but a major problem is solved, suddenly from 10 tar it will go to 10 power minus 2 tar. It is a starting trouble. It is nothing like again 1 tar you will get another trouble minus 1 tar. If you are able to solve, it will give very good solution. Otherwise, it will get stuck in the beginning itself. That is typical of vacuum technology. You will see when you are working with your systems. So, air blast and tightening, cleaning, all those things are very important. Once it is evacuated to 10 power minus 2 tar, now you switch on the high vacuum by closing the roughing walls and operating backing lines, and then switching on the high vacuum pumps. If it is a diffusion pump, continuous backing. If it is a turbomolecular pump, continuous backing with a dry pump. And if it is a cryo pump, only initial vacuum, but there will not be backing vacuum pump. You have to close that also. And main isolation valve should be carefully opened. Before that, chamber should have been evacuated to minus 2 tar, which is an acceptable vacuum by this high vacuum pump. All these things we have explained in the vacuum system of diffusion pump or turbomolecular pump. That time we are explaining as a part of pumps. Now, I am explaining it as a system. Again, these things will be explained when we are going for the application in more careful and rigorous manner, because that will be a particular problem and particular solution for a particular application. Same terms will come there again. Okay. So, you are not getting proper vacuum in the high vacuum side, then it is not like moisture alone, and you need some helping hands to understand the problem. So, they are leak detectors or RGAs, etc. From there you will get a spectrum of impurities, and with your experience, what are the materials that have been introduced inside, you will know whether degassing is there or not. Little bit bake the system, then vacuum is improving, then outgassing is solved. If it is a little leak, then try to spray some acetone vapor here and there if it is allowed, but try to keep exhaust, otherwise room will be full of closed room will be full of acetone vapor. The person concerned will get problem, breathing problem. You should be very careful while doing all these operations. A simple things can be done by spraying in the suspected portions, or else you can go for dry gas with a gauge. The simple methods we have explained in leak detection section, you can go to that section and understand. And purging also can be taken to clean in a dry way existing moisture or impurities or particulates and remove it. Then you will start getting improvement, you may get minus 6 tar. So, these repair work should be done from minus 2 to minus 6. Up to minus 2, tightening properly and air blast operation, because you need not tighten again more and more. Once mechanically it is stable at minus 2 tar, it will be stable at minus 6 tar. You will not get any other extra pressure. Vacuum itself will be able to give enough pressure, particularly all the vertical things, etc. Horizontal things you need to give little bit supports also. If it is heavy things are coming, then seals may give little wedges. So, you should be careful in giving supports. Normally in UHV people know how to do all these things. And if the problem is still there, you are not getting very good vacuum, this normally happens in UHV, then you try to suspect the leaks in the welded joints, leak check it. So, if it is unfortunately a complete system suddenly developing here and there lots of leaks, then you may have to improve the welding in the next slot. Otherwise, this problem will persist ever. So, you have to improve your welding grade itself. So, there are some methods to check on a small plates same welding, how to do that using advanced welding testing techniques. Then your company standard will go up further. Welding can be done like a rough welding that we use our household applications. Welding should be done at high vacuum. Welding will be done in a different style in ultra high vacuum. You should take care of all these things. But when you do all that, leaks may be solved, but still outgassing is a ever ending problem. This you have to solve it, never ending problem. What to do? Outgassing will always be there. Even the material with which you are making the chambers, they will degas. You cannot do anything. If the fence starts eating crop, what you can do? Like that, if the chamber is giving gases, you have to be very careful. This normally people do not care at -3 tar, -2 tar systems, because degassing is not that big. Even in chemical and pharmaceutical applications, they call it as air leakage. Leaks are more important, because that will interfere with your process gases. Because chemical processes, pharmaceutical processes, they themselves have got lot of vapors, which are used for distillation or drying operations, etc. So, small degassing or anything micro level from other things should not matter. Well, of course, if they are poisonous things, it matter, you have to be careful. But normally food grade high quality stainless steel chambers or pharmaceutical stainless steel chambers with proper welding, they will work better. But for IUHV, even small degassing is not spared, because instead of -10 tar, you will get -7 tar. You should be very careful. What are these outgassings? All the way material can come from outside, diffuse through the thickness, and then finally come to the surface, and then with some activation it will be desorbed. That is permeation. These molecules are coming all the way through the body. This is the body thickness of the shell, chamber shell. I am zooming here. So, some gas molecules may permeate through this and come out. There may be some molecules which are there within the body in the formation of the stainless steel, they will come out of it, that is called diffusion. And on the surface they are partially bound with some physical principles like van der Waals forces, etc. Then if you are trying to forcibly remove them, that is called desorption. But on the process, if they are just some sticky watery layers and they are coming because pressure is less than the saturated vapor pressure, they are called vaporizations. So, all these processes are parallelly going on, together is called outgassing for us, because they are contributing to some gas molecules, foreign gas molecules, in addition to the molecules that we need to remove to get an acceptable vacuum before we start our process, whether it is a metallurgical melting casting or a semiconductor processing or space simulation process or a particle acceleration process. Before that, all these things should be removed. So, these left side I have shown the figures, outgassing from all the surfaces it may come. And if we try to forcibly do this outgassing by baking, then we call this as a degassing, that we are doing it. If it is coming naturally from the surface, that is called outgassing, that is spontaneous gases coming out. After a long time, it will be exhausted, but we cannot wait for such a long time. We will have to do it fast by baking, etc. Then it is called degassing. Even if you do not degas, someday all the outgassing will be over, but that may be 10 years. You can do it in 2 hours if you are increasing the temperature to 300 degrees. Then comes to the fabrication issues. Then flanges, coupling should not be O-rings, then it should be metal seals, or even if O-rings are there, not neoprene, at least white-on, which can be baked to 150 degree. So, these are all interrelated: system, fabrication, leak testing, outgassing, minimization, air ballast, and understanding the process with and without load, getting acceptable ultimate vacuum without load, with load. These are all part and parcel of testing of these components and systems. That is why I have included it in this section, which deals with walls and materials. But the same testing we will also do again and again when we are going for the applications. Same outgassing will tease us again and again, same leak will tease us again and again. I will take some practical situations when we deal with the applications. So, do not mind if I discuss again and again outgassing or this one. After all, if you discuss again and again, you will get a gain, okay? Because practice makes you perfect. In vacuum technology, you should guess, it can be that, it may be this. I have seen a good student, because of continuous practice, he will be able to solve problem in 2 hours, and dull headed fellow same problem, he will take 2 days, because he will not attack it in the right place. He knows that something is happening, vacuum is not coming in the inch 4 vacuum. You should have tightened something, you should have tried something, and he says diffusion pump is not working, vacuum. He has forgotten to switch on water circulation, or he has forgotten that valve is opened or not, or he has used a bad vacuum gauge available in the laboratory. So, gauge may not be working. We will see all these things in the troubleshooting and system designs again, because system design covers all these aspects. So, how to take care of all these things, whether choice of materials level or cleaning and handling type of thing. These 2 aspects we have already covered in the earlier lectures in this section itself, dealing with materials and cleaning techniques. What we have not covered is surface treatment, passivation and backing, which are advanced processes which are normally done in high and ultra high vacuum systems. So, we will see what are these things. Surface treatment, that means basically a polishing, mechanically it should be polished, then chemically some activation layers can be done. Physical and chemical, you do whatever you like, you try to reduce the degassing problem, that is all. Whether you eliminate gases or whether you try to control or hide the gases during process, it is okay. Just like you clean the whole house before guests come, or put it in your corner and front room, you make it, it is up to you, but process has to be completed in a clean environment. How are you going to remove the junk, temporarily keeping it somewhere? It is your will. Okay. So, the surface treatment starts from mechanical polishing. This I do not have to explain, because the figure is self explanatory and I am not going to read it. There can be electro polishing also, or simple mechanical polishing. It is just a polishing pad which is rotating, and the piece which is sample which is to be cleaned, surface to be cleaned, this is connected to a carrier with an adhesive, and a small amount of slurry is kept here and it rotates here. This is also rotated. With these rotations, the surface gets continuously polished. You can also use in a chemical bath with electrolyte and keep this is an anode and other thing as cathode, and all the dust will slowly come out through the solution. These are electrochemical cleaning, we call it also as electro polishing. If you can go through this slide to understand the write up, but this is a small write up. Electro polishing is a very big field, chemical engineers know very well. Big things are kept in a big chambers, big what you call vessels, and apply a huge amount of current, discharge current, the electrolysis current. So, these are all well developed technologies. So, you please go through that. What is it we are trying to do? We are further smoothening after mechanical polishing, we are further smoothening to a micron level or submicron level, because atoms are not 1 micron type, even less than that. So, for them even micron level surface is a bad surface, submicron. If you do 0.1 micron, how do you know? It will be shining, because the wavelength, visible wavelength is of order of 0.4 micron type. So, if it is less than that, then it will be a good specular reflection. Then you will feel, you can see your image in the stainless steel sheet, it will look like a mirror. That is why called optical finish, we call it as. That is the final finish you will get by combination of mechanical polishing and electro polishing. If you can do both these things, you will get proper surfaces with less degassing, and desorption has to be minimum, whether things are happening or not. In situ monitoring will be done by RGA. If it is a high tech equipment, you can spend some more money to keep one permanent RGA leak detector to that. We will see when we discuss with the applications. And even after that polishing, you may have to passivate to remove to reduce the desorption. Passivation is nothing but keeping a dull layer. It can be an oxidized surface or it can be foreign surface, which will act like a guttering, which will not create vapor, which will only try to absorb. Such situations you have to make. like in a sputter ion pump, we are actually depositing additional layers, but those layers are actually pumping in to produce -9 torr, like titanium, zirconium, etc. These are also kept in sealed tubes to produce permanent vacuum for a longer time. Okay. So, we have to think surfaces physically polished and chemically some coatings are obtained. What is the meaning of this coating? This is called passivation coating. You are applying a barrier, so that whatever comes permeating from the material or diffusing from the material arriving at the surface, it is not going out into the chamber, thereby contributing to the load, gas load. So, we have to keep track of these things initially after physical polishing by chemical passivation. These are not usually done in -5 torr systems, etc., but in advanced systems, particularly sealed off devices, etc., passivation is a routine exercise. In fact, we use vacuum for thin film coatings, but now I am telling we apply a coating initially on the chamber inner wall. That means coating for coating applications, but this coating is a passivation coating, so that foreign molecules will not interfere with your thin film deposition or plasma deposition or electron beam deposition, which we will see later in the applications. Okay. And these coatings can be developed by the same methods which we use for thin film depositions in semiconductor industry, like sputtering or physical vapor deposition or electron beam or ion beam, like that. So, you can do all these things. You try to read these things. I am not going to explain all these things, because anyway we will have a very good section on these coatings when we deal with thin film depositions, industrial coatings, optical coatings and semiconductor coatings and varieties of solar films, solar cells. There will be a lot of situations where we will be discussing these sputter depositions and thin film depositions. Okay. And we also has to increase the temperature of the body by baking it. So, baking is a very important operation. While baking, the natural oxide layer also can take place within that small oxygen which is available, which is absorbed. That way oxygen is removed in the process of baking in the inner side. We can bake from the outside by heating, but since it is a thermally good conductor, even stainless steel with a small thickness, it will be uniformly baked. Inner surface is hot. That hot conditions, oxygen and this whatever layer, it gets oxidized. That itself will form a passivation. Or else evaporable getters can be coated. This is active barriers. They are active. After going there, they act like a barriers from the molecules not to come inside. They also act like active absorbing elements for the molecules which are there by chance, which are not the actual process molecules which we want for a particular application. The foreign molecules which we treat them as impurities, we can nicely absorb them. So, all these techniques are used together to get your very fine residual gas environment before you go for high tech in space simulation or particle acceleration or semiconducting processes or metallurgical coatings or little high tech products at -7 torr. Okay. As I told you already, baking up is a very important thing. The entire vacuum chamber will be just flooded with a heating tape. It looks little dirty, but it is going to improve. Okay. Just like when you apply a lot of soap and try to do it, it may look very odd, but later when you wash, it will you look beautiful. Same thing, will this baking is very important. When you do, you should be very careful that all the seals etc., should be compatible to your baking temperature. Okay. And what for baking? To remove unwanted things from the surface to come out faster, to degas it. Otherwise also they will come at room temperature, it will take 10 years. Now we want it in 10 hours, baking helps. Then pumps will be initially used without starting the actual process like semiconductor process, first only cleaning operations. By removing these gases by the same pumps and then get very good ultimate vacuum, which is finely related to only the unavoidable leaks, which we are going to ignore later, and then raise the pressure with your gases, if it is semiconductor growth or plasma depositions, etc. And the working vacuum can be little 1 or 2 orders beyond the ultimate vacuum which we get on a blank of vacuum. You have to take care of all that. We will discuss these things in the application areas. So, baking is a very important operation for heating it, so that outgassing later during the actual operation will be less. And you can also flush it with some dry gases like nitrogen or argon, preferably inert gases, and then again bake it before the actual process. This way you keep on improving the system quality inside before you go for actual process. Okay. If you fail in all these aspects, fail means you are getting good vacuum for most of the applications, most of the standard applications are already done, but very high tech applications you may not be able to accept even very fine leaks, even very small amount of degassing. Then if you have understood that it is going beyond your capability to get proper vacuum, because customer wants 10 power minus 10 tar, take whatever money you want, I want 10 power minus 10 tar. Then you better do some research on welding and on small plates, simulated weldings, vacuum compatible weldings. Then test it using very advanced technologies. Recently, lot of things are coming up metallurgically, advanced technologies. Material science is improving like anything. Cost effectiveness is coming up in a big way. Environmental pollution is coming in a big way. Energy auditing coming in a big way. So, materials are getting continuously improved, and world is going to make devices with high speed and compact. To do all these things, clean environments, ultra high vacuum, extremely high vacuum EHV are required. Molecular beam epoxy units can produce extremely high vacuum condition. If you want to do all that, the welding of the chamber, because within the chamber everything is going on. This chamber which is a vacuum chamber, this is going to give you commerce, this is going to give you finance, that is why chamber of commerce. Okay. This chamber and the associated components, walls, everything the engineer in the manufacturing site from the producer must be knowing, and along with the customer they should together solve the problems using advanced leak detection techniques, residual gas analysis, advanced materials using again and again testing properly, degassing, baking and passivation. All these things go hand in hand in testing. Testing is just not to get by luck am I getting or not, no. This is qualifying test before you dispatch it to the customer. That testing I am talking here. Leak testing, which is a routine thing even in the customer side, because he might have taken a very good system, they made some mistake, the manufacturer is not responsible, but he may call you, but you should be knowledgeable to help him to solve the problem. Okay. So, for that, like liquid penetrant inspection, then visual inspection with eye, radiographic inspections, and magnetic particle injection, these are coming up in a big way. So, these are all very advanced types of testing the vacuum weldings. I will not go into the details of it. For example, a radiographic inspection with these things, the output will look like this depending on the impurities. So, from the plate you can understand whether it is good or bad, then take the necessary corrective action. Similarly, you magnetize the material in the wedges or if there is any problem, and try to spray some magnetic particles and then apply some black light, and wherever there is flaws etc., you get some concentrated zones for your visual inspection. You can understand that weld, that portion is in trouble. These are all very high tech physical methods, scientific methods. Similarly, you dye it with some penetrant and then try to inspect it, and these are all advanced technologies coming in a metallurgical route. You can do that and apply these things in your actual welding. Whatever you try to improve your welding till these techniques give no leak, that particular welding you finalize, that welding you apply it in actual chamber, because in actual chamber you cannot take this analytical equipment and test the welds after chamber is made, but you have to get expertise in the beginning itself. That is why I am giving some advanced welding testing procedures. So, in conclusion, fabrication of the vacuum systems chamber components must be followed by initial testing at the site of manufacturer before it is dispatched to the customer. There also you should follow similar procedures for reducing, degassing, etc. And you should always try to aim at getting desired ultimate vacuum under no load conditions, and sometimes if there is a doubt, you even calibrate your gauge. Unnecessarily do not think that you are not getting a good vacuum. Gauge may be problem. Vacuum not coming. What are the sources? That is the question that I am going to give you later when you face the exam. Okay. What are the sources? You should write immediately. Pump is not working, conductance of the pipe is very poor, system is degassing, system is leaking, gauge is not working, valve is not opened. So, these are the silly things apparently, but they are the main things. Okay. And sometimes -6 to -3 torr it has come, but that may be a process load. You should not think it is a bad vacuum. So, you should know all these points. If problems persist, appropriate action must be taken, whether it is a leak testing or degassing. Lastly, if mechanical joints must be inspected using radiography or penetrant inspection, etc., to get a first hand experience on advanced welding techniques. Before closing the talk, I just want you to I want to remind you, when you are assembling, when you are making the system, make sure that you do all this exercise in a clean environment with gloves. Otherwise, you add some moisture with your hands, it will create millions of liters of gas at -9 torr. Be careful. And we are going to do all this leak detection and residual gas analysis in detail in the coming lectures of 36 and 37. With this section of materials, walls and components and initial testing and chamber designs and chamber thickness, all this will give you an idea. Then we will go for system design, vacuum system design, and later we will go for applications. And we will repeat all these concepts again and again. Thank you very much.